Hey everyone, and welcome back to Summarize Science. We've all seen videos of drones crashing, and often it's because a single motor or propeller fails. For a standard four-rotor quadcopter, losing one motor is usually a catastrophic event, leading to an uncontrollable tumble. But what if a drone could be smart enough to recognize a failure and adapt on the fly? That's exactly what researchers explored in this paper, titled A Tilting Rotor Enhanced Quadcopter Fault-Tolerant Control Based on Nonlinear Model Predictive Control. Their solution starts with a special kind of drone, a tilt-rotor quadcopter, or TRQ. You can see the prototype here. Unlike a regular drone, its motors can tilt independently. This tilting ability gives the drone extra ways to control its movement, making it inherently more stable and maneuverable. But the special hardware is only half the story. The real magic is in the software, the drone's brain. They use a strategy called Nonlinear Model Predictive Control, or NMPC. Think of it like a super smart navigation system that's constantly predicting thousands of possible future paths and picking the absolute best one to stay on track. To handle unexpected problems, they added a crucial component called an Extended State Observer, or ESO. The ESO acts like a watchdog, constantly comparing the drone's expected performance with its actual performance. If it detects a mismatch, say from a failing motor or a strong gust of wind, it immediately flags the problem and tells the main NMPC brain exactly how to adjust its plan to compensate. To prove their system works, the researchers ran a simulation. They tasked the drone with flying a complex looping trajectory, which you can see as the blue line in this graph. Then, mid-flight, they simulated a critical failure, one of the motors suddenly losing 50% of its power. The results are dramatic. The red line shows their advanced system barely flinching, staying incredibly close to the target path. In contrast, a similar drone without the observer, shown in orange, struggles significantly and deviates from the path. A traditional quadcopter wouldn't even be on this graph. It would have crashed instantly. They even tested it against a fault that varied over time, like a sputtering engine, and as you can see here, the drone maintained stable flight. So, to recap the key points, this research combines a more capable drone design with tilting rotors, a predictive control system that thinks ahead, and an observer that can spot and react to failures in real time. The result is a drone that is significantly more robust and reliable. What does this mean for the future? It's a huge step towards making drones safer for complex tasks like package delivery over populated areas or inspecting critical infrastructure. This technology could prevent accidents and make autonomous drones a more trustworthy part of our daily lives. That's all for this episode of Summarize Science. Thanks for watching.